All right, guys, welcome to day 5. Here in day 5, we are going to be doing a little bit of a kind of a lab day, and the downfall is you guys are virtual. Some of you may be in person as well. But what we have is we are going to be a demonstration lab where we work with static electricity, current electricity. We talk about how electrons move from atom to atom to atom. Basically, this is a build on of everything we talked about the last couple of days. All right, so in your lesson preview video, it's pretty straightforward. There's really kind of 3 things you're going to do. You're going to do your activating pre-knowledge, okay? And what you're going to be able to do is you're going to be drawing and labeling a picture of how electrons can move from atom to atom. Okay, so I want you to draw that. See if you can come up with something new besides the things that we wrote down in our notes from before. Then, once you're done, make sure that you are placing your photo below. Basically, we want this to be a quality representation of it. All right, next is going to be your static electricity demo. And what this is normally if we were in person, this is where Mr. Eddy or Mr. Wall, we'd be having a bunch of different demonstrations and you guys would be getting really involved with this. And we would be basically kind of doing a little show, the demo day. Okay, so we'd be moving up, you guys would be moving things, but since we don't know if everyone's going to be virtual or if everyone's going to be, have a chance to be in person, we made it completely virtual, and so you guys can watch it. All right, here's the deal. You guys are going to come down here. You're going to read these directions 1, 2, and 3. You're going to click on this video, and this video is the demonstration video. It's where I am up and I am kind of going through all these different labs and demos to kind of show you different ways of static electricity and current electricity and difference between like atoms and protons and neutrons and how different things connect, whether they're like charges or opposite charges, and what happens if they're like charges or if they're opposite charges, and from there. Throughout the video, I'm going to ask you to predict certain things. That's what's going to happen. When you predict certain things, I want you to pause the video and you're going to write down your predictions here. Okay. I think there's around 7. There might be one more or one less. I guess I can't exactly remember. And so what you're going to do is when I tell you to stop, you're going to write down your first prediction down here. You're going to write down your second prediction, third prediction, every time I ask you to stop. Okay. The whole idea of what we want you to do is we want you to get you thinking before I show you the results of what happens. That way you're going to be able to use your mind and kind of know what you've already used, whether it's through the notes or through what you learned in the lectures, through the other labs, or through the other lessons, before I just give it to you. So please, please, please stop the video and make your predictions. And write down your predictions, kind of complete thoughts. So you're not just writing 1 or 2 words, like you're actually thinking it out. Because if you start getting these things right, that shows you that you know what's happening and why it's happening. Because that's the key, is to know it, but then have the ability to know why it's happening, all right, and be able to explain it. All right. Then you have a couple of questions, which basically is what you find the most interesting from the demonstration and what's something that you learned from it, okay? Again, be detailed. Don't just be like, I learned what static electricity is. Okay, then go back and explain what static electricity is. All right, next we have what, again, would normally be a lab we do in person, which is the lemon battery lab. And there's actually 3 mini labs in the side of this. What we're hoping is that you guys will have a chance to do some of this at home. However, we know that you're not going to have all of these materials. And in order to send home some of these materials, it's just not realistic. A styrofoam cup's going to get broken. I don't really feel comfortable sending home a nail and some copper wire and all of that, let alone a lemon that's going to actually go bad. So instead, we have it set up where if you have the materials, great, you can do the lab. If you don't have the materials, we have the video, and during the video, just pause and answer the questions as you have it, okay? One of the things right here is this multimeter. So if you plan on doing it and you don't have the multimeter, that's okay. You can still run the lab without it, but you're still going to have to watch the video to kind of get those readings of what the numbers should be. So it's pretty straightforward. There's a little reminder of what static electricity is, and right down here, any questions that are bold, you need to answer. So first lab is a video it's a clear tape lab. Right here in the blue part is the actual lab. So it's us talking through the lab. Watch that and go right ahead. Or if you're doing the lab, just follow the steps. Once you get to the bolded questions, you will read the question, answer the question. Same thing with the video. In the video, once we get to that part, you're going to have to stop the video, answer the question, and then start the video up again. Next one, there's a styrofoam cup lab where you're going to take a styrofoam cup. You are going to try to pick up some paper, okay? You guys might already be thinking you kind of know how to do that, and this does not involve you moving the paper to the end of the table and sliding it into the cup or using your other hand and picking it up. There's got to be another way. So again, if you don't have the materials, you're going to click on the video and watch the lab. Even if you have the materials, you may want to click on the video and just watch it through once and then try it yourself, okay? Finally, here's the lemon battery video. So it's right here. And what you're going to be doing is you are going to be watching the video and you're going to be following the steps. Okay. Same thing. Black questions. Follow along. Make sure you answer them. Right here, you're going to draw what an LED is. Kind of draw, how it works and the different parts. All that fun jazz. If you're unsure, they do make Google for a reason. Hint, 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 hint. All right. Once you get done with this lab, there are 4 conclusion questions. This is kind of a wrap up from everything that you have done during that whole lemon battery lab, which would be the 3 mini experiments. Okay, so answer them. Please, in all of your answers, explain why. We're getting better at this, but remember, with being virtual or being in person and not being able to have that full-on conversation as a class, you have to be able to explain why. That's the key. I'll be honest, we really don't care if you get the right answer. We care that you can explain why that is the right answer. It's the same thing like you do in math. In math, you can get 2 times 2 is 4. But you need to be able to explain why 2 times 2 is 4. Okay? That's the key. Finally, you're going to have a Newsella article. And when you have the Newsella article, you're going to click on the link. You're going to read the article. You're going to explain 2 things that you learned from the article, and you're going to write down your article score. We're still working on an exit ticket right now. That's why this is kind of highlighted. And then right here is where you're going to submit it. Nothing has really changed. It's still relatively simple, but that is your day 5 lesson. Hope you guys have a good one, and we will